Okay, linear equations in two variables. That is done, right? I did system of equations. Do you guys forget that? That is a part of the syllabus, right? For the test. Yeah, it's there. We did it. Yeah, cool. That question came up. So yeah. Oh, real numbers is there. It's there. Yeah, there. There's a bunch of topics that are there. So get ready for them. Yeah, cool. Oh, that is not yet done. That is not yet done. A test is always on Google Forms. I have reached a point where I don't have the patience to correct papers, so I am going with that option, no matter what. No subjectives. Oh, there could be subjectives this time. I'm going for subjectives this time. This time I'm going for subjectives. Is there a test today? No. There's a test on. Why are there so many chapters in one test? Because they're short chapters, very small ones. Chotu chotu, you know, small ones, cute little ones. So yeah, so that's why. The complex numbers of the big triangle. Yeah, like me. Is there a quiz today? Yes, of course. Yeah. Anyways, half of your webcams are off, so I think I need to ask you guys to switch them on. Come on, guys. Yeah, everyone. Come on, guys, everybody. You can switch them off later, slowly, when I'm not watching one by one. At least open now when I say. Come on. Oh, God. Yeah. Uh, what are the main topics in coordinate geometry? I told you, right? Distance formula, basic things, what you studied. Okay, fine, Keithan, fine, Keithan. So that 43 out of the score of the first optic exam is out of 43, but I think your Schoolage has been updated with the 40, 50. So there are some issues. We'll sort that out. Yeah. Who can bypass your dual? Yeah, the thing is the monitors are not sufficient to hold enough of you still. Okay, so anyways, uh, yeah. So we'll start. I think I don't know whether I discussed this. I know if I show Vsauce picture and just ask you randomly, it doesn't make sense. But yeah, 1 second. Let's switch on the modes. Yep, there you go. That works for me. Okay, a triangle. When did you do? What are similar triangles then? We started. Okay. Anyways, yeah, I know. When is the volume major test? That's in the next week after that week. Reshuffling is after the volume one, I guess. Yeah. There is a shuffling that's gonna happen. Yeah, cool. Anyways, quadratic equations are done. Quadratic equations, there's nothing much. And you guys told me you guys know 100 ways to solve them. Anyways, so I'll be just adding some application puzzles for that. So let's see, we'll do a test based on that. Did I show you this? This is an awesome thing. Hello. The fun fact is you take a square around the circle and then you chop off the triangles, maintaining the perimeter. Yeah, so it goes on like this. If you keep on cutting the corners, ultimately you'll land up with repeat up till infinity. You'll prove that pi is equal to 4 because you start with the perimeter of 4. Yeah. Um, I know. It doesn't work like that. But then you apparently prove that pi is equal to 4 somehow. Question is, what's wrong? What's wrong? Why doesn't this procedure work where you're chopping off triangles like this, squares like this? Why doesn't it work? Coding class is there tomorrow. Yes, tomorrow's session is not on Python. Although, okay, so this is what I'm planning. Tomorrow there's no this week there is no hacker edition, and both are one and the same. But there is a difference. The hacker edition and this thing, there's no like that. The actual class begins at 5 o'clock. The actual class begins at 5 to 6. Okay. Before that 1 hour, there's a slot where I'll teach a little bit of Python and fix all the installation errors that are there in your systems. Okay. Please do not attend that. If you've already installed Python, do not come for that. Okay. If Python is installed for you. Okay. We'll try to find alternate solutions, and please try to use a Windows laptop if possible. I'm just asking. It's a request if it is available so that we all can be on the same page. Otherwise, it's a nightmare for me to teach on both systems. Okay. Yeah. It's going to be a nightmare. Windows 7 is okay. You can ask Nidhi about how much annoying that is, though, if it does not work for you. Has it worked for you? Has it been installed Windows 7, but not available for me? Okay, stick with Mac. It's fine. This Sunday, it's not about Python, so it's fine. But we'll try to see if there are problems. Okay, we'll do screen sharing and try. I'll try to fix the issues. Windows 10.5. That's too specific. Okay, fine. Enjoy. Why Windows? I said because PyAutoGUI works smoothly on Windows, at least for now. And there are some easy modules to deal with Windows than Ubuntu and others in Python. So as of now, that's it. Why download Python if you have issues with the online? The problem is online debuggers. I'm not teaching you Python. That's the problem. You guys are confused. I'm not teaching you any languages here. I'm not teaching you Python. I'm not teaching you JavaScript. I'm teaching you all the technologies, what you can do using it, which means that the week I give you is for you to learn the coding, learn the codes. How you're going to do it is up to you. I'm going to share you some online courses which you're supposed to take. Okay. So I'll tell you what to do. I'll tell you the instructions next week, but next week is going to be about JavaScript. I'm going to tell you to learn JavaScript. If you already learned it, great, awesome. Okay. But I'm going to need JavaScript for certain reasons. So that's the thing. Repeat the timings. Okay, that's fine. Any errors you can come. Any errors, that's fine. Any errors you can join the session at 4 o'clock. C++, no, that is outdated. What is the book again for HTML and C? This thing CSS that was by what's his name? Duckett. It's famous. It's available. Duckett. If you just search the name "Learn CSS," learn to build websites, something you'll get it easily. The book name you'll get it. Can you repeat the timings? Yeah, 4 o'clock. All the people who have Python issues, primary issues, come to me. And at 5, we start the actual sessions. Okay. And during those sessions, I'll also teach some Python. I don't know. We'll come up with some solution. That session will be boring. So there's nothing there happening, serious thing happening. But 5 to 6 is when things are going to be serious. 5 to 6, I'm saying now, but you know me. So yeah, you guys know me. Volume 1, do we have vacations? I have no idea. Look, dude, it's CFAL. What do you think we'll get vacations? Where do you think we'll get vacations? Seriously? Oh my God. Yeah. Anything. PyAutoGUI, any problems, please come. Okay. Yeah. Yeah. Anyways. So 1 second. Yeah, we continue. Look, okay, fine. I think I spoke about this reflection and all that stuff. Sorry. Remember this problem? Yeah. I'm showing you the solution. Have I shown you the solution? I drew it, but here's my approximate diagram of it. Yeah, I mean, good enough. You said about SSS. That is coming. Others can sleep till then, when that comes. By the way, I asked you to chop and then I asked you to fold. Some of you figured out something that was done. Did anybody get the answer to this problem? The thing is, none of you tried. That's a different story. But just asking though, out of courtesy. Nah. It's not 64. Okay, so maybe that's correct. Damn it. Oh, in the other class, I was supposed to pay some money. I forgot. We did this problem. We bet on it, actually. I bet $20 to anybody who solves it. And I lost $60. 3 people solved it. Guessing. No, they didn't solve it. They guessed the right answer. So that's why. $20 was this thing on it. Yeah, lol, only $20. Imagine if 10 people solve here. There are times when I lost $400 in a class to 2 students. When we used to gamble in the class. In second PUC, we have topic called probability. I mean, you have it in 10th also, but the second PUC one is much more fun. So we really played for money. I remember we gambled. All math problems are gambling only from this end to that end. I lost a lot of money, but it was fun. 20 rupees you mean because $20 is 140? No. I meant longer. Yeah. Anyways, no, I'm not going to bet here now. Chill. We did all this, but I was discussing the SSS criteria. That was done. Scales have to be proportional. SAS was discussed. There must be an angle. That was discussed. Angle criteria is all the angles have to be equal. Is that fine? Is this clear with everyone? I just need to know how many of you know this, how many of you do not know this. Just a ratio so that I can go ahead for the problems. How many of you know this? How many? I know you guys learned last year. I know some of you are new to this. Some of you are like, I want to know how many of you don't know then, particularly. Is there anybody who doesn't know? Okay, Keithan, you don't know. Okay, fine. Next. Sure. Next. Um, who else? Murali is sleepy today, I guess. Okay, fine. Mural doesn't know it. It's okay, fine. Shashank wants me to teach this, anyways. But anyways, going ahead, you just compare two angles. That's enough. There are some good Khan Academy problems. I don't know whether you guys have seen these. These are very easy problems. I recommend these three problems. You guys have to check it on your own. Okay, since everybody knows similar triangles, these basic problems are skipping. Okay, there are three problems, three good problems. We're skipping them because, yeah. Teach congruence. You guys have taught Oh my god. Okay, tell me this if you know stuff. What is this side? Basics. Come on. 4, right? Yeah, you guys know this. It's 4, 4, 4, 4, 4, 4, 4. Because it's scaled proportionately, right? This is 3, this is twice that, so this should be 4. Yeah, if they're similar, they're similar. Why are they similar? Because of the angles, 90-degree and this angle here. Done. Good. I am in a crazy mode. Okay, fine. Okay. So now what I'll do is I'll move it around. I told you, right? Moving doesn't change, preserve similarity. So if I move it there in that location, yeah, I know. So I'll place it there, and then you have seen this configuration before, right? Have you seen? Okay, I have a question for you guys. Have you guys studied geometry using configuration methods before this? As Dinesh sir taught using configurations? Okay, I don't think so. Okay. So the standard method which Shrikant told me about is an approach called configurations. It's generally, yeah, that's fine, Shashank. It's generally the method used in Olympiads. The way we deal with it is, what we do is, we only teach configurations. What we mean is, we just don't tell you what are similar triangles or anything. We just tell you where to find the triangles. So it's not obvious that this triangle is similar to this unless you compare the angles, right? There's a common angle, there's a 90-degree. Yeah, that's the part. Now, I'll tell you one more important thing now. This has some applications, you guys know. Okay, like for example, in 10th standard, we used to play this game. Now it's not a game. What we used to do was, I invented, we had this interesting idea. We want to measure the heights of people just by looking at them. Now there are multiple methods, yes, we know, okay. One of the methods we used to do was the finger. And we used to use the forefinger and not any other finger and point it towards the person. Okay, once we have pointed that finger towards the person, what we would do was we would align this baseline with the person. You can just go and ask them, I get it. Okay, you can just go and ask them. That's simpler than solving the math problem, always. Okay, but the point is, we just would place the finger that would make it, keep it at the base and make it proportional so that we could get a height measure. This is, I'll tell you what I mean. You guys solve this problem, then I'll tell you. If this is 10 centimeter and this crazy looking finger is 5 centimeter, and the distance to building is, wait, you'll understand, 2000 centimeters. What is the height of the building? Come on, tell me. You guys know this. Super easy. Why are all of you wrong? All of you are wrong. Satvik is right, except Satvik. All of you are wrong. Careful, I told you. Yeah, Shashank MN, that's it. I know you guys have forgotten one thing. Shashank MN, that's correct. All of you are wrong so far. Keithan, that's correct. Yeah, that's correct. 5 into that thing is whatever that was, right. No. Now, okay, you guys have messed up something. Yeah, Sakshi, that's correct. This is the distance to the building from the finger, guys. Which are the similar triangles? Oh my god, I'm getting answers which I thought I would never see. Okay, yeah, Mithul and Amog, you guys are right. Shashank V, you're right. Guys, which are the similar triangles? Guys, 1000 is not the answer. I'll tell you that much. 10,000 is definitely not the answer. Mohammed Neha, that's right. Yes. Nope, nope. Srivatsa, that's correct. Listen. Triangles, similar triangles. Which are the sides to compare? This and this. You guys know this, right? Yeah. Sai Pratiksha, that's correct. Agree with me on this. X by 2010 because there's 2000 plus the 10 centimeters from the face. Did you forget that your finger is at a distance from your face? Yeah. So it's 2010. X by 2010 is equal to 5 by 10. This triangle side by this thing, ratios. The ratio of this 5 by 10 should be equal to half. But this also should have a proportion of half itself. So if you solve for it, you get 1005. Okay. Is this fine? Can I get a yes or no? Can I go to the next one? Just saying. Height of the building is not 10 meters. No, this is just a 2-story building. Chill. Okay. This is not Eiffel Tower. I'll guarantee you that much. Wrong units. I know. I forgot. Bloodstains. Sorry. Yeah, more bloodstains. This looks like cockroach blood. Anyways, centimeter. Okay, I'll tell you what I meant by the technique. So, other methods when we measure is using a protractor, right? Yeah, if you remember, we use protractors, and you must have seen this. This is an app. You can use some mobile apps to do this, or you must have seen the technique is you must learn in trigonometry. This is a common application of trigonometry. You measure the angles twice, and then you walk the distance. Yeah, this is one of the methods. It always works, and they teach you in Scouts and Guides, and that's what Disha told me from the other batch. But anyways, you guys know this. One of the standard methods. The technique I and Winton used to do. We used to do it for fun. It's not like we genuinely cared about the height of the person. Okay, we really didn't care about the person. It was a math problem for us. And here's the experiment. The way we did it is you a protractor and a stone. For this, they use a protractor and a stone. Scouts and Guides use a protractor and a stone. Yeah. Now, you take the finger and align it perfectly with the building. Okay. And then, no, you didn't learn this in trigonometry, this method. And then what you do was we would bend the hand along the base point. Yeah. In the sense, we would rotate it as it is, or we used to actually only turn the finger. Actually, we would align this as the base and then turn it downward. Now, if this Eiffel Tower falls, this is where it would fall. That's where its tip would reach if the building would fall, because I'm actually proportionally comparing it. Because see, I know that there is a perspective transform and these things are changing, but if done right, that's the place where the Eiffel Tower would fall. If done right, you need to maintain the perfect angle and stuff like that. You need to use a level and check it. Yeah, we tried this. I remember in the PUC office one day with Vanitha ma'am. Vanitha ma'am stood and we measured her height. We're off by 1 feet, but anyways, that's good enough. 1 feet is a lot, but yeah, that was something though. It did work. Yeah. So we measured where Vanitha ma'am would fall if she fell flat from the position she was to the ground. You know, it was nice. It kind of worked, but our errors were within the physical error bars that we knew we were introducing. So it was fine. Horrible calculation, guys. Nobody cares about the value anymore. Oh, get ready for the volume 1 physics chapter where you'll realize we don't care about getting it accurate. Anyways, okay, going ahead. Oh, by the way, when I was searching for this problem, I found something like this. This was awesome. I don't know how many of you know about this. What happened was there's this Dutch blogger who told a bunch of people on the internet, can you Photoshop this picture for me so that you get the Eiffel Tower? Guess what people did? They wrote Eiffel Tower there. First thing they did. Second, they brought it down there. Some went on to do crazy things, such as this. Ivory was replaced with a ballet dancer. Then this happened. Some people bent the hand and stretched the hand. That was also fun. This was a great. There's a collection of 40 photographs like this. I collected as many as possible I could get. They're awesome. Each of them are creative enough. The lesson being learned is do not tell a bunch of people on the internet to Photoshop your photographs. Okay, do not request it of all the things. Okay, somebody went full Devi on this one. Okay, next, You had some amazing other these things also. Yeah, I know. So that's the full Devi pose, and they brought in some guy from the 19. Yeah, they bent the hand completely to go around the person. That happened. Uh, yeah, of course, my favorite is this one, where somebody scribbled his hand. The laziest Photoshop ever. Took the copy and pasted it on the top. There. So I think that was the most creative one so far, like the most lazy Photoshop, if you're going to do it. Yeah. That is one. And you might know this one, anyways. Um, okay, and this was a grand finale. They replaced the Eiffel Tower with the ballet thing. Okay, so something, I don't know. Heights of Photoshop. Do not tell people on the internet to Photoshop this thing. Okay, that's it. There is a great repository I found when I was searching for the Eiffel Tower photos. By the way, I also knew this, but I learned it it came up in the other batch that you can't take photographs of Eiffel Tower at night. There is a restriction like that. You're not allowed to take any photograph if you're in Paris. Yeah, you're not allowed to take any photograph. I don't know, because of the lighting I've heard. I do not know. I'm not sure. You need to watch the videos out there. You're not allowed to take any photographs of the Eiffel Tower at night. Okay, we'll continue. You guys remember this, right? This side was 4 and all that stuff. Yeah. Okay, fine. That was fine. Now, why I have no idea. Just Google. Okay. Next part. What if you take it secretly, or just don't upload it to the internet? You might have lawsuits against you. That's all. Yeah. Listen. Hope you guys are fine. Now I'll do a rotation. Is that fine? I read just god awful technique, and then a stream of messages took it away. So, anyways, I missed the messages. Okay, guys, listen. Do you understand this rotation which I did? Does rotation preserve similarity, right? Everybody fine with that? I just rotated it. That's all. Yeah. I didn't flip it. I rotated it like that. Okay. Next part. Listen to this carefully. I will mirror image this one. Mirror this one. Is this fine? I mirrored it. That's also fine. It preserves the similarity, right? Things are preserved. Next step. You guys know this, but I'm still doing it. Moving it again. Moving it doesn't change anything. Okay. Next step is I'm going to place it there. Still things are similar. Okay. Still things are similar. Now I can still scale it. I can stretch it by a slight amount. Wait, because the lights were installed after towers built and before the copyright of France tells that you cannot be brought into line of brought into a work of art. Okay. Murali knows about this. It was half interesting video. It was in a half interesting video. It seems half as interesting video. You can check it out. Yeah. Anyways, guys, you stretch the triangle till it reaches the tip. Now, you guys know this, right? This big triangle is similar to this triangle. You guys knew this before? Yeah. Just communicating that point using transformations rather than, comparing the sides and all that stuff. Okay. Wait. We're not done. So do you agree all these 3 triangles are similar? This triangle, which has a 90 degree, this one and this one, all 3 triangles are similar, except their sides are not the same, which are similar. Yeah. It's not obvious, but the thing is, this is the hypotenuse now for this. These are the ones we'll be comparing for ratios. But I'm saying these 3 triangles are similar. Is this fine? Can I get a yes or no? Hope you guys are clear with that. Okay. Now, to understand that, you have to take ratios if you really want to figure it out. But now I'm going to call them with names. I'm going to call this A, B, and C. And then I'm going to call this as AAB because of that. Then this also will be AB. Similarly, this will be P, calling it the perpendicular. Okay, naming it P. So these 2 will be P. By the way, don't go by the colors. Colors are misleading. Go with the sides. Do not go by the colors. Okay, both the lengths are P. Okay, the green one and the blue one. You guys know this. Next part. Yeah, you guys know Pythagoras theorem. But anyways, I'm not doing Pythagoras theorem. Okay. Wait, I'm not yet there. I'm going to call this C, side C, but I'm going to call this Q plus R, which means there are going to be 2 pieces. One is Q, this piece, and R piece. Is this fine? Can I get a yes or no? All the labeling so far. Everything is fine? Yeah, cool. Yes, Keithan, I'm getting there. Yeah, before that, I need a result. Do you agree with this? P divided by R You need to compare only the green sides, the color, same colored sides. They're proportional to them. Is equal to Q by P. Can I get a yes or no? Is this clear? It's not very obvious. You need to look for the angles. If you want to figure out which color is which, why? That's the thing. Yeah, I know. Look. I know it's not obvious, but I'm saying, look at the angle. This angle is here. Okay. Yeah. You can do P by Q. You can do P by Q. Okay, that is also fine. P by Q here is equal to R by P. That's also fine. Wait, R by P. That is also fine. It's the same thing, right? Fine with this. All triangles formed by the height of the right angle triangle form the right vertex are similar. Yeah, that's what I'm trying to communicate. Yes. Everybody fine with this relation? I just need to get a yes or no on this one. I'm trying to confirm this for you guys, but you need to compare. You need to rotate this. You need to visualize this. Look. Okay, I'll tell you in last one time. This blue side is similar to this Q side. I'm not saying they're the same. I'm not talking congruence at all. Yeah, P by Q is equal to R by P. No, not P by R. Not P by R. No. P by Q is not equal to P by R. That's wrong. You need to compare the sides which are similar when you take the ratios, right? Remember that? And the similar sides are the same colored ones. That is R and P here. They're not the same. Yeah, P by Q is equal to, R by P. P by Q is equal to R by P. Yes. P by Q, if you do P by Q, then it's going to be R by P. Green by blue. Is this fine? It's going to be green by blue, then, yeah, some are not getting, I'm sorry. Look, rotation doesn't help here. Yeah, rotation helps. Just rotate it, yeah. Thank you for that, Shashank. Just rotate this. Works. Fine with this. Just make it fall to the side. If you make it fall to the side, then this will be P, this will be R, and this will be B. Then can you compare now? Can you see the comparison? Now can you compare? R by P is equal to P by Q. Does that make sense? Now, whoever said, one second, I'm sorry. Whoever said they didn't get it now. That's more intuitive. Good, awesome. So that should be intuitive. Just have to make it fall down to the ground. That's all. Okay, that works. Now, once you're there, if you have this result, this gives us a beautiful relationship. P square is equal to Q times R. How many of you knew about this already? Okay. So generally, there's a comparison between P. It's Q times R. The perpendicular is related that way. Now I'm going to take advantage of that to do something interesting. I'm going to square both sides, which is going to give you, from Pythagoras theorem, from these two triangles, a square minus p square and b square minus p square. Is this obvious? Fine with this? Everybody fine with that? I'm just taking what is r square. R square is b square minus p square, and r square is Pythagoras theorem. This is 90 degree. So r square is b square minus p square, and similarly q square is a square minus p square. Pythagoras theorem. That's it. Who else said no? Did they get that now? This gives me this, and this one gives me this. You guys know Pythagoras theorem, right? Number 8. Okay. Others, it's not obvious if you don't know Pythagoras. Who else said no? Did they get that? I just plugged in for r square. Yeah, cool. We can continue. Okay, good. So with that being said, listen up. Next step is a cross multiply. Now you see that p to the power 4 gets cancelled neatly. Left with this thing. Equate it to both sides. Yeah, equate it to both sides. Bring it to the other side. This part. You have a beautiful relation. Now this relation is not obvious until you divide it by p square a square b square. You get this. It's popular. This relation, how many of you have seen this before? I know Keaton knows it. Other than that, does anybody know this relationship? This is a relationship between A, B, and P. A, B, and P. Yeah, it's famous. It's called inverse Pythagoras theorem. Okay, it's useful. It's very useful in many problems. I think it is there in your NCERT. I do not know, but the derivation is very easy. It's not really this complicated either. It was there. I know. It comes in 3 Blue 1 Bronze videos, popular ones. It comes there. Yeah, I know. Can't help. In 8th in CFL, this was there. Okay, fine. I don't know how is that taught without similar triangles, but anyways, yeah, it also comes in red black. The idea is this relationship is awesome because it's a relationship between A, B, and P, and can be useful for some interesting things, such as dealing with the light. You were there, then what was I teaching in volume 1/8? Okay, that doesn't make sense. Okay, taught similar triangles last year. Yeah, they were taught last year. Yeah. Wait, that doesn't make sense. I taught Navya, Nidhi, and a bunch of you in 8th standard, if I'm not wrong. Volume 1. Yeah, exactly. Even Anvit and all. But apparently, no offense, till date, everybody agrees with this. The batch which was by Navya and Nidhi and all, and a bunch of other people also were there. That batch was considered to be the best batch ever at CFAL, apparently, ever, 8th standard batch. Yeah, it was considered the epic batch. Even everybody agrees with it. All the teachers agree with it on that one front. It was considered the best. Yeah. Why? Because there were many awesome things about that batch. So everybody wanted to go over to that batch. I don't know, apparently. Okay. So yeah, that was one thing. The Balmata one. I'm talking about the Balmata one. That was there. Yeah. Yeah, that was fun. Anyways, with that being said, that was inverse Pythagoras theorem right there. Relationship done. Now, why do I need this? So important part for this to work, it should be a right angle triangle. Don't do this on any stupid thing and say it works. Okay. Now, why does this matter? The relationships that you study like this, see, this is a configuration. I don't know whether you agree with this. This is a geometric configuration. This might pop up in many problems. It might pop up in many other situations in your life. I don't know. This triangle may not pop up always. It may not be obvious also where it's going to come. The perpendicular has to drop from the right angle to the hypotenuse. Yeah, that's very important. It has to drop from this thing. Yeah. It's a fact. Forget the applications. I know, but I just need it for one problem. Okay, all I need is this relationship. Can you guys remember that? Forget this for now. It's fine. I just need this. Okay. With that being said, let's go to the main problem. Why I did this. Ta-da! We come to the big one, the good one. Tell me what's the answer for this. Some of you have solved it. Some of you have not solved it. Maybe. Place your guesses, not for money, because some have solved it already. So what's the point? Okay, now here's a question. Do you see the configuration which I just taught you? Can you see it somewhere? The configuration exists in this picture. It's not obvious where it is. It's not obvious this configuration works also. But the semicircle should ring a bell in your head. Yeah, I'm ready. Yeah, exactly. The semicircle should ring the bell in your head. That should be sufficient. I don't know how many of you saw this, but there was a right angle triangle sitting there. Yeah, the angle in the semicircle with the dropping perpendicular. Yeah. The thing is, what most of these students who crack these top class Olympiad geometry exams and whatever there are, what's common is they learn configurations like this. All they do is they learn this configuration, and they have to see these configurations in those problems. Okay, it's not obvious when you look at that circle that there must be a circle. You need to take advantage of the circle. But the fact that it's a semicircle should start ringing in your head that there is a 90-degree somewhere. Okay, the fact that there is a point out there which you can take advantage of, and the fact that it's a semicircle means that you can construct a 90-degree right angle. Okay, I mean, 90 degree right, a right angle is 90 degree, or you can construct a right angle triangle. But okay, I'll tell you now why that matters. Why that matters. It's not obvious. Is it the defined feature of the problem? No, but you can take advantage of this. Okay, so listen to this. I'm going to call this length A, and I'm going to call this length B, just for the simplification of the problem. Then, do you agree that this is B at the bottom? Okay, all are squares, and this is A. But this then, what will this be then? Tell me, what is this white color line that I've drawn? What is this length? Can anyone tell me? If it's a square, what is it? That is A, yeah, all of you got it. Now tell me, what is this then? What is this? I'm going to erase the A. What is that? It's A plus B, right? It's A plus B. Everybody agrees with that. Then do you agree that this is also A plus B? I can do it directly, but I'm doing it slowly. That will be very obvious to you guys. Okay, this is A plus B. So this whole length is A plus A plus B. So this whole thing is 2A plus B. Yeah, so this side is 2A plus B. Fine with that? Okay, I could have directly written it, but I think you guys got that. This will be A plus B immediately from that. And this will be 2A plus B. Fine with this? Can I get a yes or no? Everything can be written in terms of A plus B here. You can play the game. Now, with that being done, now compare these two triangles. Do you see something interesting there? Remember the relationship P, R, and S. What is the relationship? P square was equal to, sorry, Q and S, Q and S. How do you get 10? That was given in the problem. 10 was given in the problem. It was told that the diameter is 10. Okay. So this was Q, yes, Q and R, I guess. This was R. Remember this? I didn't get the A plus B thing. I told you that this is a square. This is A plus B. This whole thing is A plus B. This whole thing is A plus B. And there's a lot of cockroach blood. It's pretty today, but it's fine. They're worthless anyways. Okay. Unless in a bio lab, if you're studying them, yeah, otherwise no. Okay. Anyways, with that being said, and I hope I didn't say that. Do you agree with this? P square is equal to Q times R. I taught you that relation before, right? For a right angle triangle, this is true. Okay, what does it give you? Keaton, yeah, Keaton knows it, got it. What does it give you? B square gets cancelled nicely. Yeah, Satvik, you're right. Try it. What does it give you if you simplify this? I told you, right? This is P, this is Q, B, and 3A plus B. This is 3A plus B. There are many. There is Evan Chan, popular. Just Google the author's name, you'll find all of their books. Okay. Yes, Keaton, you're right. Yeah. Keaton, you're right. Yes. Yeah. Do you agree you get A is equal to B? I mean, you get A square is equal to AB, but at the end of the day, it's A is equal to B. Is that obvious? I'm cunning, right? Yeah. I learned my lesson when I gave that complex numbers test. No, do not draw diagrams to scale at any cost with you guys. Okay. Do not try to be accurate as much as possible. So this circle is tricky. I've messed up the circle a little bit to make it look like a semicircle, but it's actually not a semicircle, it's an ellipse to fit it. Okay. With that being said, I hope none of you asked questions in between. I didn't see the chat. Anyways, no, it's not 676. Done. With that being said, do you agree with this now? This whole thing, B plus A plus 2A plus C plus B, gives you 3A plus 2B. How A is equal to B? Simplification. Cancel. Yeah, I told you, right, Murali, all Olympiad books teach configurations mostly. Okay. I'll speak with Shrikant. I'll let you guys know. He has the knowledge of where to find these things specifically. He teaches math. No, not 2 and 2. No, not possible. You took base as 35. Why? What joy? Okay. No, not Pathfinder. Finished it. No, I'm not talking about Pathfinder. That is for physics Olympiads, particularly great. Pathfinder is great. 1 second. I didn't die. There's a microphone fell. There is no one more. No, Evan Chan. That's what I'm trying to tell you. Even this guy sent me. This chemical is sending me from that time. Evan Chan. I wrote it down, right? Standard. This is standard. Yeah, Shiva, that's correct. The previous question I had 35 as the diameter. Did I make a mistake? Oh, this was wrong. Sorry, 10, 10, 10, 10. My mistake. My bad. Okay. Now, anyways, with that being said, let's go ahead. Let's go ahead. That was correct. That was correct then. So A is equal to B. Is that fine, everyone? Yeah. If you simplify this, see, using similar triangles, you'll get that A should be equal to B. Yes, yes, Sathika, that's correct. Now, yeah, you have to change your perspective. Now, this becomes immediately, since A is equal to B, 5A is equal to 10, so A becomes equal to 2. You're done then. What is there to solve now? What is the area of this square? A square. How much is that? 4. What is the area of this? A plus B, which is 2A again. 16. Done. What is the area of this now? You can calculate. That's not hard anymore once you have A. Yes, yes, yes. If you want to do it the lazy way, this is the answer. What is this? Oh, that was a mistake. That was a mistake. I'm taking this thing. This is 1. This is different. It's 2 square. 2 square, 4. So you get 56. 56 is the right answer. Is this fine? 4 plus 16 plus whatnot. That was a typo. I don't know why I did that. But yeah, fine with this. Can I get a yes or no from everyone? Solved, problem solved. Okay, now next question. Oh, by the way, it was used in a proof, an amazing proof. You know this one, right? 1 plus 1 by 4 plus 1 by 9. If you go on adding, you get pi square by 6. Yeah, and it is connected to, where do you find these techniques? That's what I said, right? Olympiad books, all Olympiad books I have it. Give you pi squared by 6. The question is, where is the circle? And 3Blue11 does an amazing video on this. It's amazing. I show this in first PC, not here. I don't think. If that was an ellipse, then is angle in an ellipse also 90 degrees or something? Nah, it can't be. It really can't be. The reason is, wait, it can't be. Can't be. Come on. No, it can't be. It can't be. This is called the Basel problem. It's famous. Oh, this one. This was an ellipse. Which is an ellipse? Evan Chan, yeah, I don't know. I have no idea. Circle is an ellipse. I agree with that. But I'm saying in ellipse, the angle is not true, obviously 90 degree. This is a Basel problem. It's famous. Yes, the next one is called the Basel problem. It said that this is the reason why somebody quit being a lawyer and started becoming a mathematician. No, I messed up the circle purposefully to make it slightly look like an ellipse so that it made a contact at a different point rather than perfectly in half, making you think that it's a square otherwise. Yeah. Okay. Euler solved this problem. It's called the Basel problem. And the solution involves the inverse Pythagoras theorem. 1 by p square is equal to 1 by. It uses lighthouses and the fact that and uses inverse square law, which comes up in gravitation. So check it out on your own if you're interested. It's a beautiful proof. You have everything you need to solve that problem. To watch this video, you have everything you need. Okay, you don't need anything more. The video is 20 minutes. Of course, you don't have that much time. I understand. You have too much homework and a life of your own and bunch of kids and wife to take care of, wife and husband to take care of. I get it. I get it. So please look through the video when you get time. Okay, after you put your kids to sleep, try. Okay, anyways, going ahead, yeah, please watch the video, guys. Yeah, anyways, that is sarcasm. If you can't recognize that, get a life. We have a life. Okay, I have a daughter, not as you have a daughter, not as. Yeah, I know. Chill. Okay, anyways, yeah, going ahead, can I? Yeah. Oh god, I opened the video. Yeah, you had a daughter at 15. I know that problem. I regret giving that problem. I know child marriage and all that stuff. Anyways, yeah. I opened the video accidentally, but anyways, going back. Yeah, here we go. Okay, this problem you guys know. Next problem is this. I kind of regret this giving this problem in this manner, but I'll give it to you. The idea is there's a rectangle, okay, but the area of this rectangle is an integer value. Okay, it can't be any fractional or anything. The area is an integer. Okay, we know that the diameter lies between 3.5 and 4.5, and we know there's a square embedded which touches the diameter at the tip here, which is exactly 1:1. Okay, the question is, what is the area of the rectangle? Okay, it's a simple puzzle. Just take it down at the back of your head. I'm not solving it today, this one. It involves similar triangles. You can take advantage of similar triangles, but you need to see where the similar triangles are. You guys know it now. You can see from the figure, there are two similar triangles to take advantage of. But think about this. Okay, this is a good problem. Try it. It lies between 3.5 and 4.5, the diameters. Okay, that's the problem. Done. Okay. Now, this is a fun problem. There's a square, unit-sided square, 1, 1, 1, 1, everything. Listen to this, it's easy. There's a point M, which is drawn on this side, called the midpoint, and a line is drawn to it. A perpendicular P is drawn to it, okay? And that from that P is joined to C. You need to prove that D, P, and C are isosceles. I'll lead you to the answer for this one, okay? You guys are ready. But before that, somebody wanted to see the previous slide, so here you go. Please be confident if you're going to give an answer to this question, because I don't think so. Let's see. I'm not sure. Wait. No, it can't be. Can't be. No. Not 12, not 4. Somewhere it lies between those values. Somewhere the diameter lies between one of those values. Oh, what did I say? Diagonal, right? What did I call it? I don't know. I didn't hear that. Oh, I called it diameter. Oh God, sorry. That's the diagonal, guys. Okay. Yeah, butterfly, potato. I get it. Anyways. Yeah, the diameter of the rectangle. Mithil later. Done. Okay. So with that being said, guys, I've accepted the friend requests, whichever people have sent me. Depends on the account though. Okay. Depends on the account. Yeah, I know. Diameter of the rectangle. Wait, some of you sent an answer. No. Some of you are sending stupid answers. Nothing. Chill. Okay, this problem. No, that is about the friend request on Zoom. People are asking me, when will you accept? When will you accept? Oh my God. I have accepted yesterday evening the friend request. Okay, chill. Okay. Anyways, with that being said, the question is how to prove that this is a isosceles. Now, I'll tell you one more thing now. Whenever you hear the word isosceles, something else should start ringing in your head. This happens naturally for those people who solve a lot of geometry problems. But what rings in your head when you hear the word isosceles? Based on what you've studied so far. You have to prove that it's isosceles, but what rings in your head usually? Angles are equal. That's something you've seen. But which other figure out there has something similar to this? Which other figure out there has something similar to this? I'm not saying something inside it maybe, or something along with it, where I don't know. There is a common point. Listen to me carefully. You'll get it when I say it. There is a common point from which two rays come outward, and both the rays are equal. Where else does it happen? Yeah, I'm solving now because it's one line answer for this. This question is a one line answer. If I'm giving you the answer, where else do you see there is a single point from which two rays come outward? Where else is a situation where there are two arms which come outward and both the arms are equal. No. You're going through something, but for most people, this rings in their head suddenly. Yeah, Varun got it. Varun figured it out. Others. Yeah. Varun, do you see why that's useful now here? Yeah. One shot, right? Done. You see the configuration now, which you can solve the problem with. Yes, Vivek figured it out. Vivek got it. I'm guiding you there. Don't worry. There is a point, and then there are 2 points which are at the same distance. Oh, there could be more points which are at the same distance. Yes. Murali got it. Yeah, Keaton got it. Most of you got it. Yes, Shashank got it. Circle, right? Circle. Yeah. Thing is, you need to start seeing the circle here. That's the question. You need to prove some result, but do you see there's a circle which can pass through B and D like this? Yeah. The question is, you need to prove that, by the way, this is 90, right? There's a 90 degree. There is a circle hidden in plain sight. Ta-da. Done. Problem solved. This side is equal to this side, but that's equal to this one also. Done. Because of the angle in the semicircle. Done. This can be extended because this is also unit side, a square of unit side. Yep. The point is you get good at this over time. That's my point. You get very good at this. Some people get so good they can look at the problem and tell, okay. I've seen some people sit and stare at the board. I think Rakshita used to do that, or a bunch of people used to do it. They just simply sit and stare at the board. Figure diagrams are given like this. They simply sit and stare. And in their head, they simply smile. You can see the smile on their face because they're getting it step by step. They're seeing the configuration. I'm like, oh, I saw it there. Yeah, that's good. I can use that now. Okay, that configuration can be seen here. Okay, so how about do that? So that's how you deal with geometry. It's not like all those proofs which you see where you're like, okay, you need to prove that this is parallel to this and do all that crazy things and stuff like that. The beauty is seeing the configurations. Okay, how is that equal? So the equality comes from the fact that this here, I drew a circle which passes through the square. Because it's a square, I know that both sides are 1. Now, this leads us, when you extend this line to 2, it guarantees us that this is a angle in the semicircle immediately. That happens to be the median of a right triangle. Which one? Oh yeah, this happens to the median of the right triangle. Yeah, you can play around with some other games if you know the relationship between the medians. This is a median. This happens to be also the median of the right angle triangle. Yes, one of the medians. Yeah. So the game is, yeah. Geometry is all about that. Okay, seeing the configuration and applying it. Okay, I think I can go to the next. Those two sides are equal. Okay. I think we spoke about all this. So there are 2 good problems. I don't think you guys need them, so I'm just going to skip it. Good mind your decisions problems. No. That's not the answer. Just now, that's not the answer. Just saying. Should I show this? What was this video? Anyways, check it. It's mind your decisions. I'll check it out later if there's time. I was speaking of the cross ratio, right? So yesterday, I did something fun. Not yesterday. Oh, this you know, right? Missing square puzzle, the famous one. You rearrange a bunch of tiles like this, and when you rearrange, you get an additional square out of the blue. The question is, how is that possible? Everything is similar here, right? Look at it, it's similar. Can't you see that? Yeah, it's like the chocolate problem. Yeah. If you remember the chocolate problem, it's a famous chocolate problem where you break the chocolate, remove a piece, the chocolate magically appears to be proper after that. But what's happening here? Can you tell me? In the chocolate problem, it was not obvious. Here, it was obvious. Here, it's slightly harder to figure out. Yeah. Some of you are irritated by the chocolate problem. I get it. Yeah, this must have been there. Yeah, it's not a perfect right angle triangle. That's the thing. If you take slope, you'll get to see it properly. But there is a small piece of unit square that square which was missing is that thing, red thing that you see. I need to use different colors for this. Yeah, this part here. That 1 centimeter square is hidden in this entire piece here. Small slither. It's not obvious. When the movement happens, you don't see it very well. It's not a perfect right angle triangle too. Yeah, Varun, yes. Okay. So your eyes are not good tests of similarity, guys. They are definitely not. Okay. This is a fun thing I found. But anyways, I tried this now. Now, some of you might know Benedict Cumberbatch. You might know Jimmy Fallon. You must have watched the show. The show is not important here. This is one of my favorite games on the show. It's called Mad Lib Theater. Okay. Yeah, you guys know him as probably Doctor Strange, but I know him as Benedict Cumberbatch itself because, yeah, done. Because the guy is good. Awesome. The thing is, he appears in Imitation Game also. I told you about Imitation Game, right? The movie. Yeah. I know him as Alan Turing. Good for you guys. Yeah, okay, fine. Now, with that being said, Doctor Strange is shorter. Okay, good. You go with that. So what I did was I took this scene from the YouTube video, and then I want to test if the cross ratio is right. If this cross ratio thing is right, like it's correct or not. So I told you, right, I got 4 points. Copyright. No, I'm popularizing them here. I'm giving them more views on YouTube now. I bet some of you are going to go and watch now. Come on. I should be paid for advertisements here. Come on. Anyways, yeah, I could use the corners, but this is called Mad Lib Theater. It's a fun game. Please check it out. Sadly, I'm not getting paid. But anyways, what about videos where they use songs? That's YouTube copyright system. Teaching doesn't have any copyright system at all. Chill. Okay. Anyways, with that being said, I won't show the video. It's lengthy. Towards the end, if you have time, I'll just play it for you. What I did was I took this door. The thing is, the door changes perspective. So wait a minute. What this? The camera. In this case, I took this handle. These 4 points. I need 4 points to calculate the cross ratio on a line. Yeah. During the break, I'll play it. 1 second. What I did was I took 4 points. Oh my god, I've drawn those points. Why should I? Yeah. Draw a line. And this is the cross ratio. Cross ratio is you take AC times BD, which means the AC is this part, BD is this part. Okay. Then BC, the gap between them, and the full length, AD. Got the logic? That's a calculation. And I measured using an online calculator. There's an online calculator for pixel measurement. It's awesome. It's called online ruler. Just search online ruler, you'll get it. Or pixel counter, you'll get it. Okay. I measured the length of the pixels from A to C was 240 pixels. BD was about 243 pixels. You can use Photoshop for this, but that's too advanced. Why do you take the door not on your house? I need a straight line. Any straight line is fine. Then there is BC, which was 63 pixels, and AD was 415 pixels. Take the ratio, I got 2.084. Somewhere there, it looks good, okay? Now, the camera changes perspective when they hug each other at the end of the video. The door has a different perspective. Okay, now I played the same game. Previous value was this much. Took the same values. And yeah, this time it was 404, larger pixels, larger number. Took the ratio. Came to be 2.3. But my point is it could have been worse. It could be my error. I don't know. I just don't believe still that cross ratio works. But I think I must have done some errors. Let's see. I don't know. That is close. It could have been worse. It could have been worse. Okay. Now, then I took the second video. You might know about Boston Dynamics, right? This is another popular video. This video was fun. One of my favorites on Unbox Therapy. If you know Unbox Therapy, he did a video recently on this one. Yeah, Lou did it on Boston Dynamics robot. Yeah, this is awesome. This is really cool. Spot. I think I've introduced some of this to Spot. I don't know. Please check it out if you're interested. This costs now I think $75,000 currently. Okay. If you win Breakthrough Challenge, guys, any one of you, yeah, you know where to spend some of the money probably. Anyways, with that being said, like it's not like Sophia the robot. That's not a robot, guys. Come on. I don't get it why people call Sophia the robot as AI or something. It's just a basic robot. This one is intelligent. This can dance. Okay. This not only can dance, it can walk up the stairs and a lot of crazy things. Yeah, I know you don't get the money. I know. Yeah, buy softwares with it somehow. I don't know. Do what you want. Okay, show the video. You can check it out. It's fun. Towards the end, I'll show it in the break. So this was Boston Dynamics video. What I did was I took these rails. These 4 dashes are there, right? That is amazing to calculate. So what I did was I took the photograph and then estimated that length, ABCD. So first rail was the thing C and D. Anything I can take, but I took it that way. In the ISO, you have to prove that it's an ISO. Was the point which was joined to the vertex the midpoint? Yeah, yeah, that matters. That's why I wrote it as midpoint. Fine. Um, yeah, good. So with that being said, yeah, I know. Me like it, kid can dance. So that's not the point. Okay. I did the calculations, and for this one, I took the same values, estimated it roughly. It came up to 1.525258. Remember this 12558. One to this I didn't copy. Sorry, 125. Oh, 1.5258. Yeah, this is the early value. And observe what happened during the calculation. This time, the thing is, it was facing the other side in the video. So it was in the other side of the video. So this was A, this was B, this was C, and this was D. Fine with that. From the other side, this was Boston Dynamics on this side, but that was the other one. Okay. Good enough? Up to at least 1 decimal accuracy within the error bars. But the point is, it works. Now, imagine the awesomeness of this. If I just knew 2 values on this robot, I can actually get the physical distance on that one. Okay, without doing much, I can probably estimate somebody's. I don't know, on that plane, along that line. If there's anything, I can estimate. If I just know 2 lengths. Oh hell, the rain. Okay. Maybe the ruler is wrong. No, it's not about the ruler. There's an experimental error associated, and I'm dividing things. Okay, there's a large experimental error. No, it's not 4. It can't be 4. Can't be 4. I don't think so. Yeah, my voice is horrible. I know that. Yeah. Yeah. Cross ratio is useful to find, just from photographs, you can find out the distances on stuff. I don't know. It always remains constant. Okay. Sort of phrases that don't swallow the mic. No, I'm not swallowing it. It's at a distance. Okay. Yeah. Oh, remember this problem? How many of you solved it? I asked you to cut it into exactly 5 pieces. Remember? Did anybody get a solution? It's not easy. It's not easy. Okay, somebody got it. What's the method? Answer is similar triangles, guys. Okay. You guys want some time? Okay, I have the solution in the next slide. Okay, who wants the solution? How many of you don't want? Don't care was an amazing reply, but anyways, making. Oh yeah, making triangles, but how? I want a dog. Yeah, fine. Like, of all the things that are happening, serious discussion out of the blue, like, I want a dog. It must have been Anish. Cut 2 boxes each. How will you cut 2 boxes? You don't even have the grid in the background. Hey, you can't use units here. These lines won't exist in the real world. This is my, background I used. Just to verify later, I cut it properly. No, you're allowed only to draw lines. Remember this. You're allowed to draw lines only, nothing more. Yeah. D lies between yes. And D is not an integer. The area of the rectangle is an integer. This is an integer. Okay, D is not an integer. I didn't say D is an integer. Okay. Anyways, Yeah, I think I'll give you guys a break because if I play the next slide, you'll get the answer, and Murali will kill me if I show the answer. So why not? Uh, I care for my life. Yeah. So yeah. Okay, take a break. Take a 5 minute break, guys. 5 minutes, 5 minutes, quickly. Run, run, run. You're scared of him? No, that is sarcasm. Why can't you guys read that? What more can you do? Okay, I think I'll end the presentation so that you guys don't see the answer. Okay, some of you wanted that first making a triangle, then see where it cuts, and the triangle to draw a line to the base and repeat it. Mm, where will you draw it to the base? Where will you draw the line to the base? That's the question. Oh, no, no, you're not allowed to draw perpendicular lines. Nothing. Only lines. Yeah, Anika, yes. Yeah, yeah, send me the pic. Show me the pic. Send me the pic. Anything. Okay, fine. Which book did you get the problems? No, I I got it from I did you get the problems? I got it from multiple books. There are at least like 7 books that I've collected from. And I've gone to different websites, different sources and gotten these. Tell the names. No, 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 no. Not yet. Till you get the answer, no. They're not books. Half of them are not books. Half of them are not books. Some are books, some are converted into books, but no, they're not web pages. These are from Twitter. Some of them are from Twitter. Sorry. Some were given to me by Shrikant from Pew. He gave it to me. No, punish, that won't work. Oh, they're lecturers. There's the teachers, yeah. Anish, that would work. There you're using a compass also. You're not allowed to use compass. There they're using a compass. You're not even allowed to use a compass here. That's it. If compass is there, this problem is done. There's nothing. Oh, the coding assignment, chill about it. There's no urgency. That's one. Would we finish the chapter today? We just finished the chapter. We're done. We just finished similar triangles. We're left with one chapter, that's real numbers. Should we? You should get in the thesis because line segment parallel rings a bell. Yeah. So the configurations, what should ring a bell for you is, look, I'm asking you to construct 5 pieces. So that's really challenging. Instead, start thinking how can you even construct a smaller number of pieces at least. That'll give you some ideas. Don't go for 5. 5 is harder. That's the hint. Always simplify the problem. Try to construct smaller numbers. There, Thales theorem might help, but not. It's not Thales at work. Not exactly Thales at work. Something else. It's similar triangles at the end of the day, so you can say Thales, but not exactly. Yes, Anika. Where did you send the MS Paint automation? Others have sent it in different places. It was sent to my main account. Oh, Schoology. Okay. That thing I haven't opened since 5 days. So, anyways, I'll check. Okay. Did I see? Wait. I think I replied, I guess, then. If it was, I think I replied then. Wait. 1 second. My code might not work for the, yeah, it won't work for the same resolution. It doesn't work for everyone. Same code doesn't work. But that's not the point. Yes. Main topic. 1 second, I'll check if I've replied.
So we received a product, a gadget that seems more significant than usual. It's the most futuristic thing. It's not a smartphone. This is a moving, intelligent. The limp body is removed from its casket and the power switch is activated and the electricity flows from its battery. That moment right there when it stiffens up, that's the most exciting moment. All right, here we go. Oh my. It's everything. I can imagine a disruption of almost every aspect of your life, every aspect of the traditional ways in which we do things. If you can create a creature that's ultimately...
The Spot's main videos. Stealing my ears, I know. I think there were other demos of it, but yeah. No, please send it on my mail, okay? You might have seen the Boston Dynamics Spot videos, right? The other ones. You must have seen it somewhere. They can do some crazy things. This is a launch, and they did the demos a year ago. Yeah, there are some torture tests which I won't show you. That is fun. You can check it out on your own. I'll be just trying to log into Schoology for now. And I think we can get started. Can you guys turn the webcams? We get started now. Everybody, come on. Told you, right? Switch it on now. You can switch it off later slowly. Yeah. Thank you. Yeah, I hope everybody's done. Yeah, Keaton, I'll check. Thank you for sending. I'll check. Give me a moment. We started with a new chapter. Once again, I'm not seeing the chats. So Amit is here. Yeah, I'll come to that. You guys are done with actually real numbers. Have you guys been done with real numbers? I just need to know how many of you are done. Done. It was the first chapter, right? Yeah. Was started but left off. In school, it started. Similarity is done. Yeah, similar triangles are done. There's a quiz today. You guys have. I can start it earlier if you want. Your call. But there is a quiz today. Okay, we get started. Real numbers. I'll start the quiz early. Yes, immediately after the sessions, you'll have the quiz. There won't be any lag. When will you check? Did you send it? You sent it here, right? I downloaded and kept it. Oh my god, 133 MB, 1.3 MB. Oh god, wait. Yeah, I'll download later. It's downloaded. I'll check later. Okay, so this is real numbers. Is everybody here? Ashay, can you come back up from your virtual background? Why is this bridge here? That I was lazy to change the background. You know, normal me, that's all. Okay. Can you guys turn on your webcams, everybody? Come on. Yeah, typical, I know. Told you, right? You can switch it off slowly later. Switch it off. Okay, done. Yeah. There is a puzzle. I have given this last year or not, I don't know. I think Murali solved it. I'm not sure if I give it or not. The puzzle goes something like this. There are two pendulums. Okay. You know the time period of only one pendulum. You don't know the time period of the other one. You just know the time period of one of them. Okay. There are two pendulums with you. The question is, using the other pendulum, how can you measure the time period of the second one, which you do not know time period of? No stop clock, nothing. You're not given anything else. All you have is two pendulums whose one time period of one you know. Yeah. Look at the clock, it seems. Hey, if the problem was that easy, some of you might know what to do. Some of you may not. But the method, the question is, there are two pendulums. Sakshi, that was correct. The previous one was correct. I got. Yeah. That's the thing. Murali. I knew you would get stuck there. That's a good move. Yeah. Um. Simultaneously, yes. Actually, you're right. Yeah. It's got to do with that. I'll come to this idea later in much more depth. But the basics is that basics of this requires this idea. I have a fun puzzle for you, and I think you guys know this, but let's start with the first one. Yeah. I think Amit is sending. Amit, send once. I'll kick you out of this thing. Okay. Yeah. So hope that's clear. Rahul, I'll tell you. Let you know. Yeah. Yeah. I know, Murali. So the question is, Murali is right. Amit is correct. Yes. Now, the idea is, let's say we are going to play a game now. Okay. One of you can volunteer. Personally, you won't regret this, being the person who volunteered. I can assure you that. I think we'll go with Shashank for now. Sorry, Shashank MN's name came first. Okay, we'll go with Sai Pratiksha for the second one. Okay, so one of you is a robber, the other one is a police. You got to decide who's going to be who. That also matters. So who wants to be the police? First person to take the top among the two of you. So Sai Pratiksha is the police, and our driver becomes the robber. Okay, but anyways, we'll go with that. Okay, so that's the problem. Now the problem goes something like this. We have, let's say, our let's say I don't want. Let's say Pratiksha will have to catch the robber. That is Shashank. Shashank is here, and Pratiksha, you're here. The question is, these are different cities. All these points are different cities. Okay. The question is, Pratiksha needs to catch Shashank here, but Shashank can move from one city to the next in every time step, which means in one time step he'll move to a different location. Question is, can Pratiksha catch Shashank here? That's the question. Pratiksha, what's your move? You get to make the first move. Where will you go? I'm labeled the notes. You choose a point. Where should Pratiksha go? Move to 2. Okay, Pratiksha goes to 2. Shashank, where are you going next? Quickly, tell me. Quickly. Shashank MN goes to 6. Pratiksha. You need to catch him. That's all. However you want. The game is you need to catch him. Pratiksha, tell me your move. I know you're playing a strategy now. Figure out something. Move to 3. Okay. Shashank, quickly. She's planning something. You need to figure out something. 1. Okay, Anvita says Pratiksha can never catch him, maybe. Okay, that's possible. Or others, what do you think? May catch. Some of you are like may catch. Okay. Pratiksha, your move. I think so. Move to 8. Okay, she goes to 8. She can't move diagonally, only along those lines. Along those lines. It's a graph, basically. If Shashank messes up, it's possible. 2. Okay, Shashank comes to 2. Yeah, you can move only one step at a time. That's the only rule. Is it possible? I'm asking you. It's a fun puzzle. How many think it's possible? Any number of moves. This can go on forever. I've seen a problem like this and you can't win. Oh, it's not game theory. Is this game theory? I'm thinking so. Yeah, but yeah, it's kind of game theory, but it's not exactly that. I don't think it's possible. The Robin can keep invading forever. How is it solved? No, it's not game theory. It's not game theory. It's based on the chapter a little bit, but I'll come to it. Okay. Yeah. It's a common type of problem from physics. Actually, it's also a physics-oriented problem. Okay. Now, not if he goes to 11. Yeah, if he goes to 11, he's dead maybe. But your guys are saying 11 is the most important part, right? But what if I told you? What if the robber reaches 11 and whose turn it is first of all? Pratiksha's. I didn't see the number Pratiksha. Sorry. 11 and police is at 8, it's possible, yeah. Move to 3. Don't tell me because the guys are going to go back and forth. Just like that. Shashank, okay, Shashank MN goes to 1. Pratiksha, your move. 12 to... Yeah, it's possible probably. Yeah. It'll be open till 7. Sakshi. Okay. Now, do you think it's possible to catch? How many of you think it's possible? Pratiksha goes to 2. Okay. Shashank, what's your move? Quickly. Look, I'm asking you, given that Shashank doesn't make any mistake also. Shashank, what's your move? 6, done. Pratiksha, what's your move? 7. Feel like this Kalla Police game is never going to end, right? 1. These are going to go back and forth. Pratiksha, should I take over? Or Shashank, should I take over? Okay, Shashank, are you done? Okay, I'm taking over, Pratiksha. Okay, both are playing optimally, let's say. Shashank, I'll be making the move. I'm done. I'm going to 8. Tell me. This is Prajwal. Now, not Pratiksha, that's all. But it's the same. We have the same initial, so it works. Go ahead, tell me. 6, it seems. Shashank goes to 6. Okay, good. I'm going to 9. Come. Go. Quickly, Shashank. 7. It feels like he's chasing me. Okay. Done. Next. 2. Okay, done. Shashank, okay. Now let's see. Shashank, quickly. 3. Wait. Where are you going? 8. Okay. Think. Wait. Yeah, done. Next. Tell me. Next one. Your move. 3. Okay. I'm done. 1 second. Tell me. Your move. Quickly.
Tell me the truth. Do you know how to win this?
Yeah, I'm starting to think I don't know, but yeah, we'll go ahead. Wait. 1 second. Quickly. Quickly, Shashank. 8. Okay. Shashank comes 8. Okay. This is P. Done. Next. Should work. Come on. This doesn't make sense. Yeah. Shashank, quickly. 10. He goes to 10. Okay. Yeah, got it. Now this is me going back here. P. Done. Quickly, tell me. Go ahead. I think I'm done. 6. I think he's dead. Quickly. Nice. This is perfect for me.
You are coming at the place where you are starting the match.
Yeah, but it's this move now. Where is he going to go? Where are you going to go? What changed is the question. What changed throughout the game that you guys didn't see?
He did not lose still, so don't start overacting.
Hey, he has to move. He's dead. It's checkmate. Hey, checkmate. There's no check also.
This is not chess.
Yeah, I know it's not chess. I get it. But yeah. I will not move it since, hey, dude.
This is not even a game. Why should the thief feel compelled to move? Make it real life.
Yeah, I get it. But I don't know whether you guys realize
The complex numbers.
Did you guys remember a recent video of 3 Blue 1 Brown? I don't know how many of you watched. I recommended that video. That is on the chessboard puzzle. Do you remember that? Okay, I want to show you something interesting. There's something interesting about this. Does anybody get
You
an
know
idea?
what? Can a second person play this just to make sure this wasn't by luck or something? The player
Okay, I'll
playing
play
it
it.
inefficiently.
Okay. Murali, you want to go?
That indirectly meant that I wanted to go, right? Or did it come with some other meaning?
E versus M. Go ahead. Run, Murali, quickly.
Okay.
Rajul is coming for you. Yo,
Two.
my move first. Sorry. My move first. Done.
2-2.
Tell me, Murali, quickly.
2.
2. Okay, done. Murali.
There's a lag. Okay.
Yeah, okay.
1.
Done. Quickly.
You give me some time. There's a lag here.
I know. It's fine.
Hey, is this some sort of strategy you every time go to 12, take that triangle and come back?
Yes.
Yes.
I go to
I'll tell you. I'll tell you why. Give me a
6.
moment. 6. He's trying to escape now. But that doesn't help you.
1.
Tell me.
Pretty
Murali.
boring thief, right? 1.
Dead. Go. Run. Your move. No, Amit, no. Not sorry. Yeah, what?
2-2.
Wait, that doesn't make sense. Okay. Go ahead, quickly. Go ahead.
Things don't make sense with me. 7.
Okay, one second. I'll defeat you. Let's see. I have to now.
I guess the game is designed in such a way.
Game is designed so that I can win, but I'm not winning because I'm dumb. Go ahead.
Yeah, I should go around the triangle, remember.
No, I'm confused now. Why?
Yeah,
is
I go
that?
to 7.
Huh?
7. 8.
No.
3. 4.
4, you're dead. If you come to 4, you're dead.
Okay, fine. 2. The police is helping me, guys. Okay, I feel a bit cornered now. 7. Not 7. 1.
You know what I'll do, right?
Yeah.
No, it's easy to escape.
Easy to escape. What?
You know what?
Come
Why
out
should...
of the ground.
Sit there only.
No, what if I move out of the screen? 3D dimensions, right?
Yeah. This game was 3-dimensional. Yeah.
So better he could go to complex number.
Yeah. Complex games. Yeah.
Or I take up some arbitrary altitude without that.
I don't know whether you guys realize the whole time. So what is happening was when he was in red, I was in red. Okay. Yeah. Thing is, if he comes to the thing is, okay, I tell you something. So the interesting thing that was happening was I've colored alternate sides with the same colors, like alternate colors, like red, green, red, blue, and so on. That's what I've done. The adjacent sides are always of a different color. I'll come to this one. This is a special one. We'll come to it. The interesting thing that's happening is
That's why you are always going that shameless.
Yeah, I know. And it's not about that. 1 second. So he's always on red. So imagine this. If I'm here and if I'm making the move first, I'll make the move first, right? I'll go to blue. He will always go to blue. And blue and red are separated, right? So no matter what I do, whenever I make a move to red, he'll go to another red. So he'll always be far away from me. Agree with me? Yeah. Now the special part is what color to give to this node. This is a special node. What color to give? I've colored everything properly, but this one I don't know what color to give. Yes. What I do is So let's say he's somewhere in red, okay? And I'm in now red itself, same one. When I go to blue, he'll also go to blue, right? So if I go here, he'll go to blue. He'll landing up in blue. But what if I play a game where I go to green and let him go to blue? Then I can jump to the color which he's in. You got the logic, right? I'm switching colors using that one node. So you can play with this with your sisters or whoever you have. You're bound to win. If you know about that node there, that's a special node. It's
Otherwise,
a
as far
parity
as
puzzle,
I
yeah.
know you, you wouldn't play this game.
As far as I know.
You wouldn't play this game if there wasn't a way to make sure.
Yeah, I know. That's not me, of course. I know. But the point is, oh, in PUC when we play this game, I lose money because I don't know, just like that. Because in probability, the odds are always against my favor for some reason. Okay, so yeah. Anyways, going ahead. For those of you who are programmers in the room, particularly, I'm giving you a challenge. Okay, this is a challenge. It's a famous thing. I don't know how many of you have heard about this. There's something called this is like every programmer must go through this in their life, they say, if you want to be good at it. I mean, once you know enough coding, you'll be able to pull this off. It's called Euler project. It's very famous. I don't know, Euler or Euler project, whatever you call it. It's famous. There's a collection of about 600 problems. Okay, the collection of about 600 problems. This is the problem number 12. And this is one of my favorite. Try if you guys can give a solution to this. Okay, the idea is something like this. There are something called triangle numbers. The way it works is it's a sum of this sequence, n into n plus 1 by 2. Is this fine? This is a sequence. So when n is 1, what is the value? Tell me. When n is 1, what is the value? No, it's not because of the odd number of vertices. Yeah, 1, right? If n is 2, it's 3. If n is 4, you get the point, right? Yeah, that's called a triangle number. And the reason why they're called triangle numbers, have I told you? Because of this. Got it? That's why they're called. And it's a sum of the series 1 plus 2 plus 3. Sorry, oh my God. 1 plus 2 plus 3. 1 plus 2 plus 3 plus 4, and so on. Okay, it's famous, it's popular. Now, the reason why this problem is awesome is we ask the divisors, how many factors does 1 have? How many factors does 3 have, 6 have, 10 have, 15 have, 28, and so on. So 28 becomes the first triangle number to have 5 divisors. The question is, which is the triangle out there? Which is the first triangle number out there to have 500 divisors? That is the problem. And this problem taught me a lot of important things in computer science. That's what I'm giving you guys this. This is very important from a mathematician's point of view and many other reasons point of view. This is an awesome puzzle to solve. I still remember I got it in a night, but yeah, divisors are basically factors here. What we're talking about. Can this be even done with normal math? No, I don't think so. You require computers to do this. You're supposed to write an algorithm for this. Yeah, that's how Euler's problems work. You're supposed to write computer programs to solve this. You can use any language you want. Anything. You can use any language you want. You're not allowed to use modules, but that's a very important thing. You're not allowed to use any modules and libraries. You're supposed to use simple programming and figure it out. It's very hard. It's very hard. That's it. Okay, it's hard. It's not simple. It's not very like impossibly hard. I'm just saying you require ideas, slight ideas. So I still remember trying to code this up and like seeing, oh my God, this doesn't work. This doesn't work. So this is a beautiful puzzle. Try it out. It's called problem number 12. Look it up if you're interested, guys. Okay. Yeah. Going ahead, there is this fun thing. So I don't know how many of you have heard about this anecdote. It's an anecdote. An old man had 35 camels. He had 3 sons. The old man dies. His name is not Prajwal. His wish was, how do you solve mean what? Spit out the number.
Yeah, it cannot be you. Guess why?
Yeah, I want the correct number. The program's output should be that number.
No, PD. It cannot be you. Guess why?
Why? Because I'll die early.
Yeah, you're going to die young, right?
Yeah, I know. And I've decided that. We've decided. You're going to shoot me. I'm going to be stepping out of a car with suit and whatnot. It's on you.
Suit, marriage. I don't have.
No, you have to die posh, dude. Come on. Come on, you can't die like that.
Yeah,
My
cheap
wish
life,
is,
die
if you're
posh.
dying, don't die under a normal car, Maruti.
Cheap
Die
life,
under a
die posh.
BMW. Okay, yeah?
Cheap life, die
Yeah,
posh.
yeah. I know this. Yeah. You guys know about this puzzle, but here's the thing. I know. Wait a second. I'll tell you. This is surprising now. So the puzzle is something like this. There are 35 camels, 3 sons, and oldest son, the will said that the oldest son should get half the camels, the second son should get 1/3 of the camels, and the last one should get 1/9 of the camels. But there was a problem. The problem was 35 by 2 is 17.5 and 35 by 3 is 11. So it's fractions. So a wise man comes along, as you guys say, a wise man comes along who goes, he comes up with a solution. He borrows one camel from a friend. Okay, and then there are 36 camels now. So what he does is, once again, I know you guys know the solution. I had one, but that's stupid. I'll come to it once again. So let's just say he gives 18 camels because half the camels have to go to the first son, 12 camels to the second son, and 4 camels to the last because 9th of that, 36 by 9. And in the end, 2 camels are left because 18 plus 12 plus 4 is 34. 2 camels are left. He gives that camel back, which he borrowed, and keeps 1 camel to himself. How the hell did this happen? How on earth did he get 1 camel for solving the math problem out of the blue? He had borrowed 1 camel. At the end of the year, he has 1 more extra camel as a bonus, which he takes home. How? It's a famous puzzle. It's a famous puzzle, you might know. Yeah, Keaton, that's right, yes. How is this possible? It's a puzzle. Yeah, Satvik also, you're right. Yes, that's correct. No? No, that doesn't make sense. He could have taken away 1 initial camel, but then he borrowed, and in the end he ended up with more camels. 2 camels extra, that too. Not 1, 2 camels extra. What is wrong? What is wrong, tell me? How did this happen? Like, how on earth did he get? It's proper. It's proper, I know, but how did he get an extra camel? Look at the wish of the. One of the camels gave birth. No. We are not dealing with camel birth here. No. I'm sorry. Yes, maybe that's correct. Yeah, that's the point. That's a simple point. It's just about fractional add up. Yeah. Yeah, 3 of you gave the answer. 4 of you gave the answer. Any others? Yeah, Varun, that's correct. Yeah. The old man was the camel. Oh, okay. Sounds like something. Yeah. Anyways. Yeah, fractions don't add up. Yeah, you guys are right. The idea is that the fraction, if you add this itself, this doesn't add up. This is very small. It's 14 point something. Sorry, some 32 or something. This adds up to 31 or something. The problem is these fractions don't add up. 1 plus 1 by 4 plus, 1 by 3 plus 1 by 2 plus 1 by 9 doesn't add up to 1. Yeah, fractions don't add up. Okay, since the fractions don't add up, this leads to that problem. It's another puzzle. Okay, now there is a puzzle for you guys. Another. Prajwal bought some pets because he's crazy. Okay, he spent 22K on it, roughly 22K. Pets could have been dogs, 3,000 worth each dog, and parrots, 5,000 each. For some reason, they're expensive. He bought at least one of them. How many pets did he buy? You must have seen this problem before. Wait, did you guys solve this? I need to check. 1 second. Wait. Don't send the answers. I will cross-verify that I'm hoping your answer is correct. Yeah, Sakshi, you're right. 1 second. So 5 times y, yeah, that makes sense. Yeah. So Shashank MN, that's correct. And wait, later. I'll tell later. You can see the puzzle, right? Yes, Nidhi, that's correct. How did you guys solve this? I know the answer is guess. Predominantly, I think it's a guesswork. No way. Okay. Yeah, it's a Diophantine equation, I know. Yeah, hit or trial. What is guess then? Okay, hit in the sense you're hitting smartly, maybe smart guessing. Okay, we can go with that. Wait, guys, wait. Tell the question again. I've told once, only once. Done. You can see the question on the screen. Read it. Yeah, that is correct, Shashank. Answer was correct. Find a way to get money or factor out of money of either of the two costs. Yeah, that makes sense. Okay. 1 second. Sumit, that's correct. So Anish, you're sending stupid things. Okay. Yes, Keithan, that's correct. Now, how I solved it is, look, how I solved it. And this is not the Diophantine method. The problem is, you solved simultaneous equations before this, right? Yeah, Sai Pratiksha, that's correct. The problem is, have you solved Diophantine equations before this? Yeah, the thing is, listen, this equation becomes, I'll come to it. Oh God. Let's call dogs as X and parrots as Y for some reason. And no offense to all the dogs out there. 3X plus 5Y is equal to 22. Agree with this? Everything is in 1000 units, K units. Yeah. But the thing is, you know that I need to know how many pets did I buy, which is I'm trying to find X plus Y is equal to what? Basically that. Now, the way I solved it using Desmos is the following. Okay, the approach was this. I know, I get it. I'll tell you why this is complicated, why this becomes fun. Okay, 1 second. So if you look at it here, 3x plus y is 22. This is that line, blue line. But the question is, where and all does it hit? It hits at 2,4. It hits at 4,2. You get the logic, right? There are two possible solutions. One is, wait. There are two possible, not that. Oh my God, did I give you guys a value where it hits only at that point? Oh my God, okay, fine. So anyways, the point is, if you look at this red line, this is that line. So you can see that it's possible for me to buy 1.98 parrots and 3.222 dogs. But you know, that's not possible. People don't sell half a dog. Okay. You need to go to the meat stall for that. Now, but the idea is, I think if you get the idea, there's only one solution, is 4,2. Yeah. China be like, I get it. Now, with that being said, what method I followed was, I knew that x plus y should be equal to some integer. Okay, it could be some integer. So you know that if I move this line around, there's a possibility that the solutions could be 4. I could have bought 4. X plus y is equal to 4. But if I try x plus y is equal to 5, I get a non-integral answer. Not possible. What about 6? Ta-da, it works. It's possible for me to buy 6. Yeah, that's just the trial and error. I know. Trial and error. I know. Okay. One possibility is you could go with the higher value, that is 6.9. That doesn't work. So turns out whatever it is, it's obvious that it's impossible. I can't buy 8, nor I can buy, very less ones. That is 2 also. I can't buy. The point I'm getting at here is, I think I'm going to be dealing with Diophantine equations, but that's not my important idea here. The important idea is straight lines, they usually don't meet at integer values. That's my point. Straight lines, they usually don't meet at integer values like this. This is a rare case that this happens. It is possible that the problem did not have solutions at all. Okay, you solved simultaneous equations before this, right? But if I tell you you're supposed to give me an integral solution itself, then there may not be a solution always. Okay, the solution is not guaranteed always. Okay, now, have you guys studied this? I'm scared to ask. Before that, fun puzzle. Do you guys know what's the sum of this? It's called a continued fraction, where you have is equal to 1 by 1 plus 1 by and so on. What does it give you? It's a famous number. This thing gives us a famous number. Yeah, Murali, you're right. Yeah. No, not root 2. Root 2. Doesn't give you root 2. it gives you 5. Yeah, I'm revising. Could you have a program that finds solutions, but the conditions is that of math 4 of solutions? Wait. Yeah, that's the method. That's the method we use in integer programming. Standard method is we move the coefficients around, and then it's called non-linear programming. No, sorry, integer programming. It's famous. It's a branch of mathematics where we try to find solutions for that. Integer programming. As opposed to linear programming. Yeah, it's going to be golden ratio, which is equal to 1 by square root of 5 by 2. The answer for this. That turns out the answer for this is a real number. But what do you think about this? This time it's minus. What do you think this value is going to give you if you go on doing like this, a fraction like this? 1 minus p, infinity. You can calculate it. It's not impossible. The way it's done is, the way it's solved is, this can be written as, listen. This can be written as x is equal to, x is equal to 1 plus, I'll solve others for you, 1 by x. Do you agree with this? Yeah, the answer for this one is 1 plus square root of 5 by 2 for the first one. And the way it's done is, x can be written as x is equal to 1 plus 1 by x. Agree with me? Yeah, there's a quiz today, yes. Do you guys agree with this? Because this is nothing but x again, this whole thing. It repeats. Yeah. So that leads to a quadratic equation whose solution is this. It leads to a quadratic equation whose solution is this. Yeah, Murali, that's correct, yes. What does it give you in this case? It is 1 minus x is equal to 1 minus 1 by x. This leads to an amazing quadratic equation whose solution happens to be what? 1 by root 3 I by 2. The crazy part is that's a complex number. How does a real calculation like this end up with the complex number? Okay, this is something I missed when I was teaching complex numbers. I was going to show you guys this. It's an amazing result. It's surprising. Like, how does this calculation eventually lead to a complex number out of the blue? It's a continuous fraction. Continued fraction. Yeah. It leads to a quadratic equation, then you solve it, and it leads to a famous number, golden ratio. Yeah, quadratic part is a real calculation, but it leads to a complex number. The question is, this value is a complex number. The question is why? Why is that a complex number? It's a non-terminating equation. Maybe you could go with that game, but it goes on forever. Even this one goes forever. This was a real thing. There's a solution, beautiful solution to this in the 3blue11 video. I'm not telling you which one. There is one. Search it. Because you use quadratic, so yeah, probably you could go by that game. I must have gotten it because of that. But the thing is, this ultimately leads to something like that. Complex numbers are like normal numbers, I understand. But the question is, how does a normal calculation like this leave the domain completely and go to complex out of the blue? That's the question. How does it leave the domain? Yeah, not now. I can't do that. Okay. Do you guys know this? Do not kill me. Asking slowly. If you have a gun, keep it inside.
No, we don't know it.
This is no, it's not stereotype.
You should teach it.
No, serious question.
We are giving you the joy of teaching this. Enjoy.
Can you pretend as if you don't know at all and still listen?
No, I'm a fool, and I don't know this. All of us are fools. Anybody does not. You can't.
Oh, you take a non-real. You could leave the domain like that, but here we are not doing any calculation. We're just doing a calculation, which is just fractions. We're just doing fractions here. We're not even doing any, what you say. I'll tell you where's the hint. There's a hint. There's a reason why that happens and why it's connected to that specifically that special complex number. Okay, there's a reason. What, Murali? Oh, by the way, a fun question. No, listen. Yeah, I'm not giving you a hint. Have you guys studied this? How many of you haven't studied? Yeah, I can see that. I know. You're welcome. 1 second. And that's a nice short form for the cuss words. Anyways, yeah, you guys know this. How many of you do not know? Oh God, you know that you can always get a reminder R, you know this, okay, coefficient B, done.
No,
done,
we
done.
don't know it. Teach it. Teach
okay,
it.
What's the HCF of this? Tell me quickly. You know the Euclidean lemma, right? Then tell me using the division algorithm, tell me what's the HCF quickly. You do without doing it. Everybody knows? Okay, fine, you guys don't have to do it. But do you agree with this or not? Tell me. That's all. Yeah, 25 also is saying done. Fine. No. Can I get a yes or no? Does anybody not understand this? I know this was done in 8th standard. Other than Murali, does anybody else doesn't understand this? What? I didn't see that, Murali. I missed the message. Okay, for those of you who don't know what is HCF and LCM, here is a slide from your 6th standard. Have a look at it. Done.
Can you explain it, please?
Oh God. Yeah, I think I'll die explaining it. But anyways, what is this? Are you guys pretending or do you guys seriously don't know? Some of you, wait. Seriously.
I don't know. Why would I pretend?
Yeah.
Okay, you guys know the HCF, the algorithm, right? I am dying to know it. What all comments I'm getting here? Nobody knows this. Okay, fine. Okay, you guys know this. You know the fundamental theorem of arithmetic? At least know that.
What is arithmetic?
Okay, thank you. Done. You know it. You guys know the HCF and LCM of these two values? You know this, right? Using fundamental theorem of arithmetic. You can find it out directly. The point is it's the lowest of the factors involved and it's all the factors involved to the raised power. You guys know this? The LCM is that and HCF is the smallest of the factors involved. Okay. No, I know that Shivram sir did this in the beginning of one of the sessions and you guys have learned it in school also. So you guys are dying. So I'm basically stabbing you twice right now. I get the feeling. I know it. I've been there. I told you, right? In PUC, I had situations where I had to teach JEE mathematics and then teach NCERT. So you can imagine. Okay. Yeah, you guys also know this from a screenshot of your favorite textbook, NCERT textbook.
Quite a feat for a eye-brain-celled noob at PU.
Yeah, I know. Anyways, you guys know this problem? People running in a circular field. There's a girl by the name of Sonia and Ravi. I don't know, for some reason they're running in the field and you're asked to calculate when will they meet again. Yeah, so you guys know that. There's a good video, My Mind Your Decisions, but before that, I want you guys to open something. I think we'll do it next time. Yeah, that'll be introduction to the next class. That'll be the last class. I'll be finishing real numbers. There'll be some problems we'll have to solve. I wanted to do a demo, but we'll do it next time. Do a demo. Till then, you open it if you're interested. Download this software. It's on techmind. I'll send it in the group. Okay, 1 second. That doesn't seem to work. 1 second. It's called TechMind. I have opened it 2 days back. Yeah, it's called Spectrum Analyzer, TechMind. I'll send it to you. It will work for those of you who are. No, I'll just send it to you. You guys open it and install it if you're interested. Yeah. So that's the software. Download it. It's just a few kilobytes. It gives you the spectrum analyzer. Now, if you have other good softwares like Adobe Audition or Audacity or any other good software, those also do it. But this one's sole purpose is that. Okay. Just download it and keep it. It gives you the spectrum analyzer. It gives you the frequency in your voice. So I think I have it somewhere installed. So 1 second.
Could you tell us why we need that with respect to this lesson?
Yeah, we need. I'll come to that. I'm doing an introduction to something in a different way, but hope you guys can see my stupid voice. I'll just show you once what my voice looks like. It looks beautiful,
looks
right?
like?
Yeah. on a logarithmic scale. What and all frequencies are present. If we whistle, I think you might get particular notes, but you know what my, wait, let's amplify the amplitude scale to around 8x. Yeah, 8x is great. On 13x, yeah, that works. So this is what my voice looks like. Please open the software and play around with this. Sing to it. I don't know, some of you might know Let It Go, sing to it. And some of you might know, I don't know, your favorite songs. Some of you suggested you guys love Demi Lovato, try that. Start singing to it, whistle, or download an app which can play sine waves and see what happens. You'll get some interesting results. It might burst. Start singing. No, I'm not doing it. I have a terrible voice. If I start singing, you will don't want to hear anybody sing for the rest of your life. So chill, okay? Don't get excited about my singing.
The software is having a tough time.
Yeah, the software, he is having a tough time with what? It's doing well. It's doing well. Okay. Yeah. So good luck with that. How to download? I sent you the link, right? Just go to that and go to the site and just download it. It's there. I sent you the link in the chat, and here down when you scroll, there is download. Just download it. Okay. Yeah. Cool. That's about it for the day. Your quiz starts now in some time. You guys can jump out of the classroom. Bye bye. Please sing once. Nah, you don't want that. You remember that time there was a Justin Bieber joke where they said that, you know, I listened to Justin Bieber's song. I was almost clinically dead. Then I woke up just to switch off the music speaker because Justin Bieber's song was playing. Yeah, it's like that. The dead will rise if I start singing. You don't want that. Yeah. Anyways, with that being said, just download this software. It's worse than Tahirsha. Tahirsha at least has a voice. He may not have a great song. He has a voice. Okay. How do you make the cursor go in a circle using pi out of gi? That's a problem for you. Figure it out. You know coordinates, right? You know coordinate geometry? You know points on a circle. What do they look like?
We don't know. Can you teach it again?
Oh my God. Oh, by the way, do you guys know parametric equations?
No.
Oh, this is something I need to teach you guys. This is fun. If you guys have time only. If anybody wants to stay, they can stay. Otherwise, no. This is very useful. In fact, functions are stupid. I personally don't like functions. Direct, like regular expressions. Which KB to download? The first one, the recent one, 16 July. That is the best one, I think. It works.
If you like these things, then I'm out.
Okay, that's a good definition for you to be out. But anyways, how do you pinpoint exact location on the screen of something? How do you think when you draw a circle in paint that the computer knows that I have to color those pixels? That's the game. That's where integer programming comes in. It's complicated because you're shading pixels here. You're not shading just this thing. So use a floor function. Use a floor function to get an approximate this thing. But that's not the only thing that I care about here. It's you just need to you need to make use of the equation x square plus y square is equal to r square. Yeah, that's all. See, find a x, then find a y, plot it. That's all. But it will give you some approximate answers. Okay, now I'll tell you why this matters. Don't, I guess. Parametric equations I'll teach you when I'm teaching physics. Volume 1. It's going to be very useful there anyways. So, but read up about it. Read up about parametric equations when you get time. Volume 2. I call that volume 1 because there is, what is that? It's mechanics, and mechanics usually comes first in CFL. That's why. Is there some way to show resolutions where the mouse pointer is kept? Yeah. It's called trump.position or pi out of gui.position. That works. pg.position, whatever you want to call it. Okay, so tomorrow's sessions, I'll set up a list of what's going to happen tomorrow in the coding sessions. You'll get instructions. I told you, right? Do not come at 4 o'clock. Come there only if you want to die. If you'll be bored to death, come at 5 o'clock if you really want to sit into the class. But other details will be Python installation. Okay, if you want installation help, that's the time you're going to come. What is that robot's name? That is Spot. They have good ones. I like Atlas. Boston Dynamics Atlas. I don't know what will happen when that robot gets. I need C++ help, not me. I am not the guy for C++, but yet you can send it. I'll understand if there's an error. Common errors I can debug. Yeah. If classes think I might make PPT for game. If classes go beyond July. Oh, by the way, your classes are not starting. Your regular classes will never start till January, at least. Forget that. January, February. These classes will go till July, and yes, I agree. Oh, coding classes, they will go till, I think, I don't know. I have no idea. Coding classes, they'll go on as long as I'm alive. I don't know. Let's see. I mean, according to Murali's predictions, I'm dying someday, right? Before that, I'll teach and go. Okay, chill. Yeah. Your regular classes are not starting yet. Forget them. They are just start, even if the vaccine comes, the chance that you might get it in November. In November, your classes might start. Worst case scenario, it will go till next year, January, April, somewhere there. Unless the vaccine comes along. Your 1 year is gone. It's called the 0 year. What about the air filter made by India? Air filters. Let's see how will that help. No, more than that. I have no idea. Unless it comes from the New York Times or Huffington Post or Times of India. And some of the reputed channels, others with fake news. Yeah. Syllabus has been reduced. I heard that. What's wrong with them? What is seriously wrong with them? I'm telling you. Yeah. Like, that is like stupid.
Why? Why is that stupid?
Look, you have no idea. Look, our syllabus was better than yours back in the day. Okay, we had entire those we used to get Bosco's textbook. I still remember. The syllabus had something that was useful.
Social science is reduced. Kannada is reduced. Everything that's good is reduced. I'm happy.
Okay, so math is not reduced.
Everything that is
math
bad
is
is reduced.
Math.
Yeah. Math is reduced, I think. I don't know.
After
Science
filling
is
the Python,
reduced.
my control B is not
It's reduced only to the concept.
So once again, and with whoever is doing the control B thing with the command prompt, go to Sublime Text Tools. There's a build option. There's build with. Do not go for that build with has been changed from Python to something else. You have to save it as Python. And when you save the file, you may not have saved it as .py. That must be an issue. If nothing works in computer science, there's one solution for everything. Restart the computer. Okay, that's all. That's been the solution. And it's been said that once a mechanical engineer, computer science, software engineer, and there was a physicist in the car going, and they get the car stops suddenly out of the blue. So immediately, I think the physicist says, okay, maybe there's a fault with the engine, and we need to go and fix it. So immediately the mechanical says, I know the engine better, so maybe there's an issue with the the steering, and there's an issue. Immediately the computer science engineer, let's just get out of the car and get inside. That will solve the problem. Okay, that's a typical computer science thing. I'm not kidding. Why don't you wait? Have you uploaded the quiz? Not yet. I'm waiting. Why don't you destroy the virus? You prank on biologists. No. I love biologists. They're my favorite. I just have problems with chemists. That's a little bit. Okay, chemistry only. Not even chemists exactly. I don't have problem with chemists. I just have problem with, it's like there's one organic chemist I love too much. Okay, there's one out there who I love too much. But other than that, I hate everybody. Okay.
Murli.
I didn't say that. Okay, anyways, that's it. So with that being said, yeah, why can't I build anything? Look, you require physicists to build machines and all, whatever. You don't require physicists, you require engineers who follow the instructions of physicists at the end of the day. So anyways, I have a problem with biology. I have a problem with biology records only. Okay, that's all. There is no other problem with biology I have. Yeah. So as a topic, it's fun. My favorite topic in biology, I've told you, right, is animal behavior. Please read it up. It's a fun topic. It's my favorite till date. I never got to study it, but I used to borrow notes from the other batch who were bio students and read it. Okay, anyways, I think I'll publish the quiz. I think till then you can see the boring spectrum analyzer of my voice, me yelling, my screaming and whatnot. 1 second. You guys can make a move. I mean, leave, make a move and don't start dancing. Bye-bye. Please sing. No. You guys have an opportunity to sing if you're interested. We are watching videos on animal behavior every class. Yeah, that's fun. But you need to study the spider behavior, particularly the mating rituals of spiders. Did you know that the spiders have to build, with a web, they build a gift for the female spider and they offer it. There's an offering ceremony. There are many ceremonies, by the way, in the animal kingdom. You check it out. It's fun. It's interesting. Yeah.
You love only that part.
What? Oh, it's fun. Those are the parts that are fun. I still have I still remember the notes of biology where the words for the first time boyfriend and girlfriend were used. Okay, I still remember that. Yeah. It's not the main thing. It's just that the fun part is leading up to the basic. Its behavior is awesome. I'm like, how do these creatures, small creatures, know that they have to exhibit such complex behavior? Okay, yeah, that's seriously complex behavior, to be honest. Okay, I'll execute the quiz. I'm just trying. Are you talking serious or immediate? No. I was pulling the notes from some other biology students in my bachelor's. I was doing physics bachelor's. The people who used to doing, yeah, they used to give me the notes. I'm publishing the quiz. It's on the way. You're not at the end of the world. That's why. I don't know what's the answer to. I have no idea what is that answer to. 2020 seems like the end of the world anyways. I hate bio cause you have to keep so many names. Oh, taxonomy is not fun. For that, you use Google Lens, guys. That's done. It does the job. Google Lens. How many of you use Google Lens? Has anybody used Google Lens here? I think most of you use it, right? Yeah, please use it. Quiz is on the way. I am adding it to your this thing. It's on the way. It's similar triangles. Get ready. My internet is not like, it hates me. Oh, come on, quickly. BSNL, prove yourself. This is your one chance. Done. It works. I think you must have received the quiz. Get ready in 5, 4, okay, 10, 9, no, 30, 29. Wait, this is taking longer. 1 second. 1 second. This is going to take time. Why is it not loading? You stupid. What is this? I can't set the due date for the assignment. I'll set it later. Okay, I'm sending it to you. The quiz should be live in next 5 seconds. Wait. Done. Assigned. You should be able to see. It's not reset. I have to change the instructions. Quiz is there till 8 o'clock. Your time till 8 o'clock to answer that quiz. Good luck. Bye, guys. Take care. Okay, it's not assigned. I think I lost the internet. Oh, come on, BSNL. Why are you doing this to me? Yeah, I know you can't see the quiz because it's not assigned. Google Classroom is acting weird. Okay, wait a second, guys. Google Classroom is giving me problems. Give it like 1 minute. Okay, 1 minute. Yeah, give me like 1 minute. It's done almost. Just 1 minute, 1 second. Yeah, now it's working. Good. And 8 p.m. Done. Your deadline is 8 p.m. You can answer the quiz. We're starting now. Hopefully works. Assign. Why is your voice going perpendicular? What are you guys talking? Okay, done. Got the quiz?
Not coming.
Now reload the page. You should be able to see that quiz in your Google Classroom and hence the answer script.
Now it's there.
Yeah, we can see.
Okay, I can go and I can leave the class. Bye bye, guys. Take care. See you guys tomorrow. Sadly.